Hello everyone. Today we are going to study the application of the two-body problems. First topic is the hyperbola. Second topic is a hyperbolic orbit. Third topic is scattering. Then we study the flyby, Voyager's trajectory. And the last topic is the orbit in space. Let's move to the first topic, is a hyperbola. If a point P moves so that the difference of the distances from the two points F and F primes, F prime is a focus, is constant, then curve described by P is called a hyperbola. So we consider the 2 points F prime and F, and the distance between the two for C to the point of P. If you consider these triangles, draw this triangle, this distance is y. This is gonna be minus c minus x. So this length is expressed minus c minus x square plus y square root. This is equal to the square root c plus x square plus y square. This corresponds to the first terms. And the second terms is expressed c minus x square plus y square root correspond to this terms. The difference between the two lengths is 2a. So you can express it. This is equal to 2a. These are definitions. Hyperbola. Then we move to the practice 3.1. Derive the following equations from the definition of the hyperbola. Definition of hyperbola is given by this equation. Maybe you can add the absolute values. Then we can express this square root x plus c square plus y square minus square root x minus c square plus y square equal plus minus 2a. Then take a square root x plus c square plus y square equals plus minus 2a plus square root x minus c square plus y square. Then take a squares in the both sides. Then left hand side becomes x plus c square plus y square. Right hand side becomes 4a square plus x minus c square plus y square plus minus 4a square root x minus c square plus y square. Then y square is gonna be cancelled, and x square and c square is also cancelled out. So it becomes 4a square root x minus c square plus y square equal, so this part is x square plus 2cx plus c square. This part is x square minus 2cx plus c square. X square and c square is going to be cancelled out. So we have a 4cx. So it's going to be 4cx minus a square. Then 4 is going to be cancelled out in the both sides. So you should plus minus sign. Then take a square in the both sides. Then it's gonna be a squared x minus c square plus y square equal c square x square minus 2c a square x plus a to the fourth. Then this part is gonna be x square minus 2cx plus c squared. And actually we discover the same terms here and here. So we can express this becomes c square minus a square x square minus a square y square equal a square c square minus a square. Then divided by this terms, it becomes x square over a square minus y square over c square minus a square equal 1. So finally we got this equation for the hyperbola. Then if we introduce the eccentricity is defined the very same ways. E equals c over a. Substitute into the x squared over a square minus y square over c square minus a squared equal 1. So c equal a e. Substitute here. And then we have this equation. Instead of c, we can use the eccentricity. Then we can express hyperbola with a polar coordinate. So in this case, we choose the origin is located at one of the focus. So in this case, this is the origin. Then this is r and f. This point is expressed r cosine f, r sine f. If you choose that this is the origins. But in the case of the x, y coordinate, origin is here. This is a. You have to subtract. So x is expressed r cosine f minus a, and the y is r sine f. Okay, so this is a relation between the polar coordinate and the Cartesian coordinate. Then we can move to the next practice. Use the two different expressions for the hyperbola. So this is x equal r cosine f minus a, y equal r sine f. So one of them is a Cartesian coordinate and the polar coordinate. Using the definitions of the hyperbola, we derive the following two equations. This is the question. So we start with the equations for the x squared over a square minus y squared over a squared e square minus 1 equal 1. We can multiply the a square, e square minus 1 in the both sides. So it becomes e square minus 1 x square minus y square equal a square e square minus 1. Then you can substitute x equal r cosine f minus a, y equal r sine f. Then it becomes e square minus 1 r cosine f minus a square minus r square sine square f equal a square e square minus 1. Then we can expand these terms. E square minus 1 r square cosine square f minus 2ae r cosine f plus a square e square minus r square sine square f equal a square e square minus 1. Then actually we can combine this to this. So it becomes e square cosine square f minus 1 r square minus 2a e square minus 1 cosine f r plus a square e square minus 1 square equals 0. Then we can consider this is the equation for r. Then it becomes e cosine f plus 1 r minus a e square minus 1 e cosine f minus 1 r minus a e square minus 1 equals 0. So from these equations, this is 0 or this is gonna be 0. So there are two possibilities. So if you choose the first term is 0, r sub 1 is a e square minus 1 over e cosine f plus 1. From the second factors, r sub 2 equal a e square minus 1 over e cosine f minus 1. So there are two possibility for the r. So what's happened to the r? If you draw the hyperbola, this is hyperbolic orbit. Then this point is minus c. So we choose that this is the origin if you consider polar coordinate. So if you choose that this is r, f, and then this is gonna be, there are two intersections for the two curves, hyperbola. So first one is a short distance. This is correspond to r sub 1. The other one is a longer distance. This corresponds to r sub 2. So especially if you consider a pen, f equals 0. Then r sub 1, it becomes a e minus 1. This is c minus a. This corresponds to this one. This is c minus a. And r sub 2 equal a e plus 1. So c plus a. So this is a. This is c. So this point is the distance is c plus a. Okay, so we can express the hyperbola with a polar coordinate.